Hello friends, today we are going to see the trick to solve common collector amplifier sums. Let me tell you, till now we have seen common emitter without RE and with RE sums, okay, and now we are going to see the trick for common collector amplifier sums, okay. In both the video we have seen how to use RE model for C with RE and C without RE, okay, and in this video also we are going to see how to use RE model and save time, okay. So let's start with the very first sum. This sum is from EC 1993. Yes, I know this is very old, but it is very much helpful for understanding the concepts, okay. So the sum is for the amplifier circuit of figure, the transistor has a beta of 800. The mid-band voltage gain VO by VI we have to find out of the circuit, okay. So you can see this is the circuit and this is the option, okay, and in the question you are given to find out VO by VI, okay. You can see output voltage is VO and input voltage is VI, okay. So this question is saying that you have to find out output voltage upon input voltage, okay. So you can say this question is asking to find out the overall voltage gain, okay. It is not saying you have to find out internal voltage gain, and let me tell you, in most of the sums you will have to find overall voltage gain only, okay. So let's start with the solution that we have to use, okay. As we know, we have to use RE model, okay. So in RE model we know we have to find out R pi and we have one current control current source, okay. We have to get this R pi also, okay. So for R pi we know the relation that R pi is equals to beta by GM, okay. So basically here in the question you have given with beta, right, but we don't have GM, okay. GM formula is mod of IC by VT, okay. So from this you can clearly see that we have to use DC analysis. In this question, DC analysis parameters like IC and VCE is not directly given, okay. So basically we have to go for DC analysis to get this IC, right. So first of all, what we will do is we will do DC analysis, okay. In DC analysis what we actually do is we open circuit all the capacitor, okay. Basically we do DC analysis with frequency equals to 0, so that's why we open circuit all these capacitors, okay. So we will be remaining with only this circuit, okay. So here you can see this circuit is a voltage divider circuit, right, and to solve voltage divider circuit, first we have to convert this circuit into Thevenin equivalent, okay. So in Thevenin equivalent, first we require VTH and then RTH, okay. So VTH will be simply the voltage across this 100 kilo ohm, okay. So it will be 100 kilo ohm upon 100 plus 200 kilo ohm into 15, right. So VTH is this one, okay. So you can see here this 0000 got cancelled and 3 ones are 3 5s are 15, right. So our VTH is 5 volt, right. Now for RTH will be simply parallel combination of these two resistor, okay. So it will be 100k parallel with 200k, okay. So it will be 66.66 kilo ohm, okay. Again, for calculation of this parallel resistance you have to use gate calculator, okay, and I hope that you have seen my video how to use calc to find out parallel equivalent resistance, right, in a second, okay. So let's move further. So we got VTH equals to 5 volt and RTH equals to 66.6 kilo ohm, okay, and if we resolve the circuit we will get this circuit, okay. Our motive is to find out IC, right. So here you can see this is a PNP transistor, okay. This is your emitter, this is your collector, and this is your base, okay. We all know that we don't know anything about this VBC, right. We only know the information about VBE, okay, and that is usually 0.7 volt, okay. So what we are going to do is we are going to apply the KVL in this fashion, okay, from ground to ground, okay. So it will be minus 15 plus 0.47 K into IE, okay. Here I am assuming all the resistance in kilo ohm such that I will get all the current into milliampere, and this makes our calculation very easier, okay. So if you apply KVL we will get minus 15 plus 0.47 K into IE plus 0.7 plus 66.6 K IB plus 5 volt equals to 0, okay. So if we simplify it we will get minus 15 0.7 and 5, it will be minus 15 plus 5 is minus 10 plus 0.7 it will be minus 9.3, okay. If we take minus 9.3 at that side we will get 9.3, okay, and if we take IB common from all this we will get 0.47 K. 1 plus beta is 800 given, so it will be 801 plus 66.66, okay. And as you know that we have already taken resistance into kilo ohm, so our current will be in milliampere, okay, or you can think in this way that your K is taken common and 1 upon K is nothing but milliampere. Okay, so our IB will be, if you simplify it, you will get 0.02 milliampere. Okay, and we know the relation that IC is simply beta IB, so our answer will be 800 into 0.02 milliampere, so we will get IC as 16.78 milliampere. Okay, so this is IC. Okay, we get our IC. Now we can find out our R pi. R pi is beta by GM, and for GM we have the formula that is mod of IC by VT. Okay, in room temperature VT is nothing but 26 millivolt. Okay, so we are going to use VT. In the question, VT information is not given, so we are assuming room temperature only. Okay, so R pi will be mod of IC by VT. Okay, mod of IC we get 16.78 milliampere, and upon 26 millivolt, 10 raised to minus 3 will get cancelled, and we will be remaining with 0.64 ohm. Okay, so you can see here R pi is very small in this case. Okay, so we will assume it as 0 ohm for simplicity, that we will see in the simplification later. Okay, now let's move ahead with the AC analysis. Okay, we have completed with DC analysis part, and we have successfully find out the value of R pi. Okay, now we want our RL dash, AV and all. Okay, we know AV formula is VO by VI, basically output by input. Okay, here you can see VI is already used. In our previous video we have seen that in place of VI we were having VS, so at that time we take the notation here, that is VI. Okay, but here the thing is, in place of Vs in the question it is mentioned that our Vs is basically Vi, so here we are using different notation, that is Vi dash. Okay, so our AV, basically internal voltage gain, will be VO by Vi dash. Okay, in previous video we have seen the two way to find out our AV, that is by VO by Vi dash, or with this formula, that is AI into RL dash by Ri. Okay, in this video also we are going to see both ways. Okay, so let's start with the first way, that is VO by VI dash. Okay, so first we want VO, right? So you can see the VO is nothing but the voltage across this RE. Okay, else you can use KVL or basically V equals to IR. Okay, so here you can see we have IB current through this and beta IB current through this current control current source. Okay, so in this branch we will have IB plus beta IB. Okay, so it is nothing but 1 plus beta IB. Okay, so the voltage across this RE will be VO is equals to 1 plus beta IB into RE. Okay, and now for VI dash. VI dash is basically a internal voltage, internal input voltage. Okay, so for our VI dash, either you can use KVL or basic rule, that is V equals to IR. Okay, if we use KVL here, we will get minus VI dash plus IBRB plus 1 plus beta IB into RE. Okay, so you will get this thing. Okay, if we take Vi dash to another side, we will get R pi IB plus 1 plus beta IB into RE. Okay, now in numerator and denominator you have seen that IB is there. Okay, which you can take common and cancel it. Okay, so if you simplify it, we will get this as a formula. AB will be 1 plus beta RE upon R pi plus 1 plus beta RE. Okay, so this is the thing that you got from this VO by VI dash formula. Now let's use this. AB equals to AI into RL dash by RI. Okay, I am showing you both ways because some students use this and some students use this. Okay, I usually prefer both of it as per the situation. Okay, so here you can see our RL dash is nothing but RE only. As you can see, we are taking output voltage from emitter, right? So our RL dash will be resistance across the emitter side. Okay, so here you can see we have only one resistance, that is Re. Okay, so RL dash will be Re. Okay, so as per the formula, RL dash is R. And now this current gain is nothing but output current upon input current. Okay, so here output current is IE and input current is IB. Okay, IE we can write it as 1 plus beta into IB, right, upon IB. So if we cancel IB, we will get 1 plus beta. Okay, so our AI, basically internal current gain, is 1 plus beta. Okay, now coming to this Ri. Okay, Ri is basically a internal input resistance. Okay, for internal input impedance we want Vi by IB. Okay, so either you can use KVL to get your Ri, or you can simply see that if we take this Re somehow to this side, we will get Vi by IB. Okay, so if we take this Re somehow to this side, we will get Vi by IB. Okay, so either you can use KVL to get your Ri, or you can simply see that if we take this Re somehow to this side, we will get Vi by IB. Okay, so if we take this Re somehow to this side, we will get Vi by IB. Okay, so either you can use KVL to get your Ri, or you can simply see that if we take this RE somehow to this side, we will get two resistance in series. Okay, so to say two resistance in series, the current should be same. Okay, so here you can see we have IB and here we have 1 plus beta IB. Okay, so to make the current same, what we are going to do is we are going to consider our emitter resistance as 1 plus beta into 470. Okay, so in such case you can see that IB is the current flowing through this RPI and IB is the current flowing through this 1 plus beta into 470 ohm. Okay, so in this way you can see our Ri will be simply R pi plus 1 plus beta into 470 ohm. Okay, so our Ri will be R pi plus 1 plus beta into RL dash. As you can see, RL dash is nothing but Re. Okay, you can also use KVL to do this. Here you can see we have already calculated our Vi dash as Vi dash is equals to R pi IB plus 1 plus beta IB into Re. Okay, if you take IB at this side, you will get R pi plus 1 plus beta Re, which is same as this Ri. Okay, so you can use either of it. Okay, so our formula will become Av equals to 1 plus beta RL dash R pi upon R pi plus 1 plus beta into RL dash. Okay, if you want to by heart the formula, then by heart this, because there may be many resistance here across this Re. Okay, so it's a good practice that you learn the formula with RL dash. Okay, but I recommend that you to derive this formula instead of by hearting. Okay, so if we put all the values here, we will get 1 plus beta RL dash, we know it is Re. Okay, so if we simplify it, we will get 1 plus beta Re upon R pi plus 1 plus beta Re. Okay, as we already know that R pi is equals to 0 from DC analysis. Okay, so if we keep R pi equals to 0, then we will get 1 plus beta Re upon 1 plus beta Re. This is this thing. Okay, so here you can see we get internal voltage gain which is nearly equals to 1. Okay, now in the question we require overall voltage gain. Okay, and the notation that we use for overall voltage gain, that is AVS, and it is nothing but VO by Vs. Okay, but in the question in place of Vs it is written that VO by Vi. Okay, so that's why we were using Vi dash, right? So we have to find out VO by Vi. Okay, and here in the question if you see it, here we don't have any RS. Okay, so whatever the voltage you have here, it will be same here. Okay, so you can say that Vi dash will be simply equals to Vi. Okay, so you can also say that your overall voltage gain will be equals to internal voltage gain. Okay, so you get your overall voltage gain nearly equals to 1. Okay, so our answer for this question is AVS, which is nearly equals to 1. Okay, and let me tell you, this is a common collector amplifier. Okay, and if you see, we are taking output from emitter, and this circuit is called as emitter follower circuit. Okay, so mostly you will get your voltage gain as 1 only, because at that time only you will get the same voltage as of input voltage. As the name says, this is emitter follower circuit. Okay, so whatever the input voltage is, that voltage should reflect at the output end. Basically that voltage should reflect at the emitter end. Okay, so that's why this name is given emitter follower circuit. Okay, now let's see another sum with RS. Okay, so here you can see, here we have given with this parameter. This sum is actually asked in GATE 2006. I forgot to mention the stream. Okay, so let's see this given data. Given data is GM is equals to 20 millisecond, beta O is equals to 50, RO is equals to infinity. This is also the part of your AC analysis. Okay, we will see where it is located. Okay, the question is asked the voltage gain AV is equals to VO by Vi of the amplifier is. Okay, and the options are here. Okay, so very first thing that we have to find out R pi, right? As we all know that we have to get R pi for RE model. Okay, so R pi we know the relation, that is beta by GM, and here you can see we have beta and GM both in the question only. Okay, so you can say that in this question we are not going to use any DC analysis, because if we were not having these two parameters, then at that time only we are going to use the GM formula, that is mod of IC by Vt. Okay, and that time only we have to do DC analysis for IC. Okay, but in this question the GM value is directly given, so we can use this relation to get our answer. Okay, so our R pi will be 50 upon 20 into 10 raised to minus 3, so it will be 2.5 kilo ohm. Okay, so you get your R pi. Now we can move on with the AC analysis. Okay, so here you can see we have used RE model, and this is your RS, this is your VI, we usually say it as VS, and here it is your RO. Okay, so note one thing, this is your R pi, this is your RE, and this is your current control current source, and this is your RO. Okay, if you have clearly see in most of the sum I didn't draw this, but here to show you the exact location of RO I just have drawn this. Okay, in most of the sum you will always get your RO is equals to infinity. Okay, so that's why it is not needed to draw this again and again. Okay, so in this question also you have RO is equals to infinity, so we will neglect this RO. Okay, and we'll open circuit it. Okay, so now we have to find out AV, right? AV is VO by VI dash. We can use both, either VO by VI dash or the formula that is AI into RL dash by RI. So let's use this VO by VI dash wala. Okay, so our VO will be simply RE into 1 plus beta IB, right? So this is our VO. VI dash will be simply IB into R pi plus 1 plus beta IB into RE. Okay, so you can use either KVL or just you can use V equals to IR, Ohm's law. Okay, so it will be IB R pi plus 1 plus beta IB into RE. Okay, so you can clearly see IB is common, so you can cut from numerator and denominator, so you will get this 1 plus beta RE upon R pi plus 1 plus beta RE. Okay, so this is your internal voltage gain. Okay, and if you put the values what we have from the question, then we will get 1 plus beta as 1 plus 50 into 2k. RE is 2k here. Okay, and R pi we calculated as 2.5 kilo ohm plus 1 plus 50 into 2 kilo ohm, which is nothing but 0.976. Okay, so we get our internal voltage gain as AVS. Okay, but in the question we have to find out VO by VI, basically overall voltage gain. Okay, which we say it as AVS. VO by VS, in the sum it is mentioned VS is nothing but VI. Okay, so that's why we have used internal voltage as VI dash. Okay, so AVS we can write it as VO by VI dash into VI dash by VI. Okay, this thing we have not done in our previous, because in the question there was no RS. Okay, but here we have our RS present. Okay, so we have to find out this VI dash. Now VI dash and VI is different. In the previous question VI and VI dash were same. Okay, so we have to get that. Okay, so that's why we have distributed this VO by VI dash into VI dash by VI just to get in terms of internal voltage gain. Okay, so you can clearly see we have to find out this. Okay, so basically we have to find out the ratio of VI dash by VI. Okay, so for that we are going to use the internal circuit. Okay, and we are going to use the resistance which is very much close to this RS. Okay, and you can see the resistance which is close to RS, which is nothing but RI. Okay, so we are going to use RS and RI. Okay, so if we calculate what is the value of RI is simply R pi 1 plus beta RE. Okay, so here you can see RI is nothing but R pi plus 1 plus beta into RE. Okay, as you can see, to make the current same, basically to make the same IB current flowing through this resistance, we take R pi as R pi and RE as RE into 1 plus beta. Okay, such that we get the same current, that is IB. Okay, so basically we can say R pi and 1 plus beta RE is in series. Okay, so that's why our RI will be R pi plus 1 plus beta into RE. Okay, either you can use KVL or you can just directly use this. Okay, so if we put all the values we will get 2.5k plus 1 plus 50 into 2k. Okay, so if you solve it into the calc, you will get 104.5 kilo ohm. Okay, so our internal part circuit will become like this: VI, RS, and this is your RI. Okay, and the voltage across this RI is simply VI dash. Okay, so if we use voltage divider rule, we will get VI dash as RI upon RI plus RS into VI, right? So VI dash is nothing but 104.5 kilo ohm upon 104.5 plus 1k, it is nothing but 105.5 kilo ohm into Vs. Okay, so VI dash upon Vs, basically VI dash upon VI is nothing but 104.5k upon 105.5k, which is nothing but 0.99. Okay, so we got this parameter as 0.99. Okay, so if we simplify it, we will get 0.976 multiplied by 0.99, it is nothing but 0.966. Okay, and from the option you can clearly see that it is closer to this A option. Okay, so our correct option will be this A option. Okay, so here in this type of question you have clearly seen that we have to use only RE model to solve this type of sum, and we are going to save much more time as compared to hybrid model. Okay, in hybrid model you have to remember hybrid numbers and the circuit also is complex. Okay, but here with RE model the circuit is very simple. You have to use this relation. If you don't have beta and GM directly in the question, then you have to go for DC analysis, or you don't need a DC analysis if this beta and GM is already given in the question. Okay, and in the AC analysis, if RS is not present, then your overall input voltage will be equals to internal input voltage, and if RS is present, then you have to use voltage divider rule to get your ratio, that is VI dash by Vs. Okay, so that's it for today. Thank you guys.